So those customers in the mold making industry that are looking for higher precisions, FANUC has given us the software and the technology to make those realities come true.
Nowadays, parts are getting smaller and smaller, and also they need to be more accurate or precise. Now, Bill, what are customers demanding from you in part accuracy and precision, and why are they demanding that?
Great question. So today what we're seeing is a lot of people they're looking at speed. How can they get the job done faster? And faster doesn't normally mean that the wire is cutting faster. It's getting to the end result in a faster time. So in the past, there may have been 3 to 4 different passes, or rough and 3 skims, or rough and 4 skims, again, depending on what you're doing, to get to that surface finish and accuracy that you need. Nowadays, we're trying to get to that finish, that accuracy and finish, and we are getting there with less passes. So the time for cutting an individual wire may be longer, but the overall time is actually less, which is the most important. How much time does it take to cut that part, so you can get another part in the machine? And how we do that is FANUC uses programming logic in their pulse mode designs, so that continuing testing goes on in FANUC Japan and around the world, Europe as well, and in North America. And we report back on some of the findings that we have from FANUC. And when they decide to release a new technology, it gets released in a software update. Now, any machine from Methods, any FANUC machine that gets installed at the customer's facility is automatically updated with the latest software. So the machine design doesn't change from within a series normally. And the latest technology, when it hits your floor, you're getting it like it just came off the factory floor. So any of that programming technology or any of that behind the scenes electronic changes or new pulse modes that are being developed are available in the control, as well as if there were any bugs in the past, those are eliminated because we're actually troubleshooting those here in our technical center before the software is even released to the public for their use.
Absolutely, and there's a huge difference when you update the control of an EDM. There's a much bigger difference in the actual resulting cut, accuracy of the cut, surface finish of the cut, than there would be with a milling machine or a turning machine, right?
Yes. So again, the pulse mode, there's a lot of magic behind that at FANUC. That's the trade secret that they have, but these pulse modes now are allowing us to get straighter parts in the microns now with open conditions. In this instance, we're doing a taper. It allows us to control the speed of the wire at the top of a cut in a taper versus the bottom. So that allows us, again, to increase the accuracy. So those customers in the mold making industry that are looking for higher precisions, FANUC has given us the software and the technology to make those realities come true.
And let's talk a little bit more about the demonstration you've got here. So you're talking about tapers. I didn't realize that obviously to achieve a longer cut at the bottom and a shorter cut distance at the top, you have different wire speeds. What effect does that have on the resulting component?
So when you have the wire traveling at different speeds, what we call in different speeds, because we have a shorter path around the top versus the bottom of this part, you'll get an overburn sensation because the amount of power that's going through the wire can't be regulated from top to bottom. I mean, you have a consistent voltage that's going through the wire, and you also have a different pulse mode that controls how the spark is taking place. With a simple test cut, we can predict what that factor is for an overcut. When we have, in this instance that we have here, 25 degrees, we can predict how far that wire is going to overcut on the top. We can make a compensation in our technology, and then the top and the bottom will come out to spec without affecting the surface finish or the time of the cut.
Wow, I'd never even considered that there'd be this kind of precision requirement from a taper cut like this. There's also another demo you're showing us, which is on a slightly smaller machine. What kind of demonstration is that?
So we have a C400. It's a standard machine, but it's a factory option, ordered from the factory. We normally keep 1 or 2 machines in our warehouse in case we need to turn them over for medical or semiconductor industry. It's called the thin wire machine, and we basically use 2000s and 3000s wire to cut extremely small profiles in varying thickness pieces. This is very, very big in the medical industry for microsurgery. And again, with the FANUC control and the technologies for the 2000s and 3000s, so the thin wire, we can cut some pretty accurate parts very, very quickly.
Absolutely, and you're showing the actual inspection of the components as well. And you're achieving some really tiny radii, and what you call the kerf, I guess, is when the wire just goes straight through the material.
Goes through, right. And we do that in the technical center, is we have our technical center to do the test cuts, and we have the equipment, because we can say we do it, but we want to prove what we've done. So we have our laboratory microscope that we can take pictures on, so we can support some of the claims. We can support all the claims that we make for the wire cutting, as well as zoom into some of those small intricate surfaces to show the accuracy of the FANUC machine in those corners.
And if you've got some really hard precision requirements and cycle time requirements to keep customers happy, come challenge Bill and the team here at the Technical Center, because they might surprise you.